In this video, you're going to learn what we mean by intermolecular forces, that there are three common types of intermolecular force, and the difference between these three types of intermolecular force. An intermolecular force is simply an attractive force between neighbouring molecules. There are three common types of intermolecular force, namely 1. Permanent dipole-dipole forces, 2. Hydrogen bonds, and 3. Van der Waals forces. All of these three forces are very much weaker than ionic or covalent bonds, which bind atoms and ions together in elements and compounds. We have a video each on ionic and covalent bonds if you haven't learned about them yet. Let us now look at these three intermolecular forces one by one. First up are permanent dipole-dipole forces. A polar molecule is one in which there is a permanent dipole, arising usually because the different atoms in the molecule have different electronegativities, the attraction by a bonded atom for the pair of electrons in a covalent bond. Let us take hydrogen chloride as an example. Hydrogen chloride is a polar molecule, as the pair of electrons in the hydrogen-chlorine bond are nearer to the chlorine atom. In other words, they tend to one pole. The chlorine atom has a stronger attraction to the electrons because it has a greater electronegativity than the hydrogen atom. We can represent the hydrogen chloride molecule as H, delta positive, and Cl, delta negative. Thus, there will be an attraction between the delta negative on the chlorine atom of one molecule and the delta positive on the hydrogen atom of a neighbouring molecule. The diagram below shows the permanent dipole-dipole force between the two molecules of hydrogen chloride, indicated here by the red dashed line. The second type of intermolecular force is the hydrogen bond. The permanent dipole in a covalent bond between a hydrogen atom and a fluorine, oxygen or nitrogen atom is particularly strong. Thus, the attraction between the electron-deficient H delta positive of one molecule and the lone pair of electrons on a fluorine, oxygen or nitrogen atom of another molecule is much stronger than the permanent dipole-dipole attraction mentioned before between the two hydrogen chloride molecules. This particular type of dipole-dipole attraction between the electron-deficient H delta positive of one molecule and the lone pair of electrons on a fluorine, oxygen or nitrogen atom of another molecule is given the special name of hydrogen bond. So, a hydrogen bond is the attraction between the H delta positive of one molecule and the delta negative on the lone pair of a fluorine, oxygen or nitrogen atom of a neighbouring molecule. Even though a hydrogen bond has only about 5% the strength of a covalent bond, it does have a significant effect on the physical properties of compounds. For example, were it not for hydrogen bonds, both water and alcohol would be gases at room temperature and pressure. Number 3. Van der Waals forces. Firstly, note the spelling of van der Waals forces. It is a lowercase v in van, and the apostrophe comes after the s in Waals. Van der Waals forces are induced dipole-dipole interactions. Let's look at how these arise. They arise out of movement of the electrons in the shells. If we could freeze the action at any moment in time, there would be an instantaneous dipole at that particular moment. These induced dipole-dipole interactions, called van der Waals forces, occur in all molecules, whether polar or not, but are the only intermolecular forces between non-polar molecules, such as the halogens and the noble gases. As the number of electrons in the molecule increases, so do the van der Waals forces. This explains why there is an increase in boiling point as we go down the group of halogens and down the group of noble gases. So, to recap, an intermolecular force is simply an attractive force between neighbouring molecules. The three common intermolecular forces are 1. Permanent dipole-dipole forces, 2. Hydrogen bonds, and 3. Van der Waals forces. hydrogen bonds exist between a hydrogen atom on one molecule and a fluorine, oxygen, or nitrogen atom on a neighboring molecule. And a fluorine, oxygen,